One thing we learned about linear pair using the linear pair postulate is that the angles forming a linear pair are considered to be supplementary. If they are supplementary, that would mean that the sum of their measurements is equal to 180 degrees. This is the concern for this video. We are assumed given the condition that angles L and S are forming a linear pair. So this is more or less similar to the video pertaining on practice exercises concerned on the supplementary angles. So for that video, we're still going to use here the formula for the angle addition postulate concerned on supplementary angles, telling us that the sum of the measurements of angle L and angle S must be equal to 180 degrees. Again, this is supported by the linear pair postulate, telling us that angles forming a linear pair are supplementary. So we just simply need to use this formula for items 1 to 3 and simply substitute the given. For item number 1, angle L is given to be 58 degrees plus the measurement of angle S, which is the unknown, should be left as measurement of angle S, must be equal to 180 degrees. Next step is to subtract 58 degrees on both sides. And we now have the measurement of angle S being the difference of 180 degrees and 58 degrees, which is more or less 122 degrees. Please correct me if I'm wrong. Okay, 122 degrees. Yeah, 122 degrees. To show that this is really correct, we can just simply use our checking here. And our checking should use this formula. And we need to substitute the values and should retain the equation. So the measurement of angle L plus the measurement of angle S must be equal to 180 degrees. Measurement of angle L is given to be 58 degrees plus the measurement of angle S, which is given to be 122 degrees, must be equal to 180 degrees, still question mark because we are just checking. And sum them up. 58 degrees plus 122 degrees is equal to 180 degrees. The other side will also become 180 degrees. They are now balanced. That would mean the measurement of angle S is equal to 120 degrees, the correct answer for number one. For number two, you simply need to again use the same formula because linear angles forming a linear pair are considered to be supplementary. So let's use it here. The measurement of angle L plus the, let's make it better, angle L plus the measurement of angle S must be equal to 180 degrees. But here, since the measurement of angle S is given to be as a binomial with a variable, we still need to solve for the value of x before we can solve the measurement of angle S. And to do that, we have 105 degrees for the measurement of angle L plus x plus 4 degrees is equal to 180 degrees. And then we just simply need to continue. You have x plus 109 degrees is equal to 180 degrees. And then subtract both sides by 109 degrees. We now have x is equal to 180 degrees minus 109 degrees is equal to 71 degrees. Let's use this value of x to solve for the measurement of angle S, which is given to be x plus 4 degrees. X is 71, that's 71, pardon, degrees plus 4 degrees, and this would actually become 75 degrees. That's the measurement of angle S. Let's do the checking. If the measurement of two angles will yield 180 degrees, and if they will rather, we are assured that our answer is correct. So the measurement of angle L is already given to be 105 degrees, plus the measurement of angle S computed to be 75 degrees. Question mark. Is it equal to 180 degrees? Yes. 180 degrees is equal to 180 degrees. They are now balanced. That would mean that the measurement of angle S, which is 75 degrees, with the use of the variable x computed as 71 degrees, is the correct answer for number 2. We have one last item here, but then again, in this last item, both of the angles are not given with with not given exactly. They are given as a expression with a variable. Still, our formula will follow as the measurement of angle L plus the measurement of angle S to be equal to 180 degrees. Substitute the given x plus 61 degrees plus x minus 23 degrees is equal to 180 degrees. We continue. You have 2x is 61 minus 23 is positive 38 degrees is equal to 180 degrees. And then we subtract both sides by 38 degrees here, 38 degrees here as well. So you will have the result of 2x is equal to 180 minus 38 degrees is 142 degrees. Divide both sides by 2 and we will get the result for x, which is 71 degrees. This is the value that we will try to substitute for the given algebraic expressions for both angles, and we will check later on if if it could satisfy the equation. So we will have here the measurement of angle L is x plus 61 degrees. So you will have the result 71 degrees plus 61 degrees is 132 degrees. And the measurement of angle S is equal to 71 degrees minus, let's try it first with the variable x minus 23 degrees. X is 71 degrees minus 23 degrees will yield 48 degrees. All right. This is the measurement of angle S, and this was the measurement of angle L. Let's check for the final step for this for this practice exercise is to make sure, that's L, that the given equation for linear pair, which is actually supplementary, will be satisfied. So the measurement of angle L is 132 degrees plus the measurement of angle S being 48 degrees. Is it equal to 180 degrees? The answer, yes. And since they are equal, that would mean measurement of angle S is correct to be 48 degrees. The measurement of angle L is correct to be 132 degrees. With the use of both of them, used the value of x, which is 71 degrees. So again, the relationship between angles forming a linear pair is that they are adjacent angles that are supplementary. So we still use the angle addition postulate specifically for supplementary angles. Wherein if we're going to add them up, the two angles, they must their sum of measurements must result to 180 degrees. So this is our second to the last video for this lesson number 2, angle pairs. The next one, the last one, will be concerned on the last angle pair as of the moment. So please stay tuned and see you on the next video. Goodbye.